Okay, so in this video, we're going to have a look at exponential equations. If we look at part 1 here, we have 3 to the power of x equals 81, and we are being asked to solve for x. So first thing I need to do is try and rewrite the right-hand side of the equation as 3 to the power of something. So we know, and again, you can just use your calculator for this. 3 to the power of 0 is 1, 3 to the power of 1 is 3, 3 squared gives me 9, 3 cubed gives me 27, and then on your calculator 3 to the power of 4 will give you 81. So then we can write it as 3 to the power of x is equal to 3 to the power of 4. You see here we have a common base, so we can cancel it, and then we get x is equal to 4. And that's our answer for part 1. These types of questions are pretty straightforward. Part 2 then has a little bit more work to it. So we have 2 to the power of 2x plus 2 to the power of x minus 6 equals 0. So our goal here is a bit of manipulation and substitution. So we can set up a quadratic equation. So first thing I'll do is rewrite using my log rules. This is the same as 2 to the power of x squared and what I'm going to do is swap out 2 to the power of x for y. So my next line then will read y squared plus y minus 6 equals 0. And just to tidy it up, we have a quadratic y squared plus y minus 6 equals 0. We'll go for guide method, factors of 6, 1 by 6 and 2 by 3. We need to end up with plus y. So I'm going to use 2 and 3. It'll be plus 3 minus 2. So we have y squared plus 3y minus 2y minus 6 equals 0. So y times y plus 3 minus 2 times y plus 3. So we have two answers here as it was a quadratic. So y equals minus 3 or y equals 2. So we have two cases here and we'll deal with them separately. So we had said we were going to let y equal 2 to the power of x. So for my next line I will get minus 3 equals 2 to the power of x. And like earlier in example 1, my goal here is to rewrite minus 3 as 2 to the power of something, but we know we cannot do that, so we put an x there and say that we cannot solve. And if we check our second case, we get 2 is equal to 2 to the power of x. Left hand side I'll just rewrite as 2 to the power of 1. We see we have a common base of 2, so I can cancel that. And we end up with x equals 1. And there's our solution. And part 3. Just a little bit more of a difficult version compared to part 2. So we have 5 to the power of 2x plus 1. Minus 5 to the power of x minus 4 equals 0. Okay, first thing we'll do for indices rules is rewrite this first part here. So we'll have 5 to the power of 2x multiplied by 5 to the power of 1 minus 5 to the power of x minus 4 equals 0. And then again, like the start of the previous example, this would be 5 to the power of x squared multiplied by 5 to the power of 1, we can just leave as 5, minus 5 to the power of x minus 4 equals 0. I'll always use my middle term as a guide for what I need to let y equal. It's usually in the simplest form. So it's 5 to the power of x. So we get y squared multiplied by 5 minus y minus 4 equals 0. So 5y squared minus y minus 4 equals 0. For guide method, we get 1 by 4, 2 by 2. Need to end up with minus y. Sorry, it'll be 4 by 5. Gives me 20. So 1 by 20, 2 by 10, and 4 by 5. First two are no good. I have 4 and 5. I need to get minus y. So it'll be minus 5 plus 4. So that's 5y squared minus 5y, 4y minus 4 equals 0. So we get 5y, y minus 1, plus 4 times y minus 1. Separate your brackets. Okay, so I have my two cases and I'm going to set them up. We have y equals 1 or y equals minus 4 over 5. And we had said earlier that y was going to equal 5 to the power of x. And I found two answers for y, so now I can substitute in. So I get 1 equals 5 to the power of x. And my goal here is to rewrite this left side as 5 to the power of something. So we know that anything to the power of 0 gives me 1. So that means 5 to the power of 0. We have a common base of 5, we can drop that. So we get x equals 0. And now we check our second case. So we get minus 4 over 5 is equal to 5 to the power of x. And we have no way of rewriting that as 5 to the power of something. So again, we just put an x and we say that we cannot solve. And there's our solution. And just to show you a quick way to double check both of these answers is you can just sub it back into your calculator. Whatever answer or answers that you find for x, just sub it in and check. So you'll see here for part 2, we got that x equals 1. So we have 2 to the power of 2 times 1 plus 2 times 1. 2 to the power of 1 minus 6. All into your calculator will give you back 0. But not a necessary step to show on your workings. And that's those 3 examples done.